Well, welcome to section 1.1 on evaluating expressions. First thing I want to do with you today is talk about a few vocabulary terms we'll be working with. The first is a variable, and I know you've worked with variables before, but just wanted to reiterate, a variable is a letter that is used to represent one or more numbers. So what you will end up seeing likely for variables in our class, well, the one you will see the most is just the letter X. Because of this, whenever we are talking about multiplication, we're going to have to represent it in a different way. So if you look down here, this is the expression 5 times the variable n. And so you can use parentheses to show multiplication. You can use a dot to show multiplication, or if it's a number being multiplied by a variable or two variables being multiplied together, you can put them literally just right next to each other with nothing in between, and that will also mean multiplication. So just want to give you a heads up, because if you are using x as showing multiply, that's not going to fly so well in this class. So start using one of these other three methods to show when you're multiplying something when you're writing things on paper. Other letters that might be used, A, M, N, and I want to just make a comment on our letters here for L and T, because if you're like me, when you're writing a word that uses an L, let's say my last name, Kimball, I just do a straight up and down line for an L. So why the heck did I use this fancy cursive L here? Well, because if I am talking about the variable L and the number 1, it's really hard to tell the difference between those two straight lines as to which is which. So if I'm ever talking about a variable or something that's just needs to be the letter L, I will always use the cursive L to represent that. Same thing with a T, except instead of it being similar to the number 1, a T could look really similar to a plus sign. Because looking at those two, I don't know which is a T and which is a plus. So when you see me use the letter T, it is always going to look like the swoopy T with sort of that J sort of shape hook off to the right side. You don't have to do those necessarily, but wanted to give you a heads up that I will. So those are variables. Now, something else we'll be talking about is algebraic expressions. Now, expression, or an algebraic expression, is just an expression that includes at least one variable, because algebra is the point at which we start using variables to represent things. So for it to be an algebraic expression, it needs to have that one variable. This is different than an algebraic equation, because if you look at the word equation, if you look at the word equation, the first half of that word is equal, which means we need to have an equal sign, whereas an expression doesn't have an equal sign. So we could have 5 times n. We could have 14 divided by y, or you could use just the dividing symbol for 14 divided by y. It would mean the same thing. You could also do 6 plus c, or 8 minus x. All of those would be algebraic expressions. So now let's evaluate some expressions, both by hand and on our calculator. So what we're going to do is we're going to evaluate the expression when n equals 3. Because of that equal sign, what an equal sign means is what's on the left is exactly the same as what's on the right. It just might look different. But what that means for us is that every n that we see, we can replace with a 3. So that means we can replace that n with a 3, we can replace that n with a 3, or this one, or even that one. So if we want to go and rewrite those then, that would give us a 13 times 3, a 9 divided by 3, 3 minus 1, and 3 plus 8, which would give us answers of 39, 3, 2, and 11. Now what I want to show you with this as well is how to do this on your calculator, because you've got these fancy new graphing calculators, and I want to be able to help walk you through how to use those. So here is your basic graphing calculator. it's over here on the left, but over here on the right, it was just a sort of enlarged version of the top screen, so you can maybe see what's on the screen a little bit better. Now, a couple things I want to point out. All of your numbers, your decimal point, all of that is down here with the white buttons. On the right side is your gray button. So you have your addition, subtraction, multiplication, division, and your enter button just tells it to find the answer. So if you want to do 3 plus 3, it's not going to find the answer until you press enter, and then it will give you the answer of 6. Or 9 divided by 6, enter, would give you 1.5. The black buttons are all of the other different things that your calculator is able to do. So if you need parentheses, those are here. If you want to do 5 squared, you could do 5, and this x to the second power here actually just is a shorthand for getting you to square something. So 5 squared will get you to 25. Another option, especially if you need powers that are higher than 2, is you could do like 5, and then this little caret right here on the right side, like 5 to the third. And that'd be 5 to the third power, which is 125. Or if you just want to do 5 squared, you could also do that here as well. Now, if you notice, the calculator continues to display all of your previous equations. If you want to clear those off just to make your calculator look a little nicer, when you haven't typed anything new, all you need to do is just hit this button right here that says clear, and that will clear it all blank for you to start over. If you get here and you realize, oh crap, I forgot to write down what that last equation was or what the answer was, another nice cheat with this is you can just press second and enter, and that will bring up your last equation. If you wish that you had the one from 2 previously, you can just do that again, second enter, and now that would bring us back 2 equations. And it actually has a good number stored, I think about 10 equations or so you can keep going back if you need to find other options or other equations that you had previously. Let's say, though, when you got here, I wanted to, instead of doing 3 plus 3, I wanted a 13 plus 3. Well, to add just one character in, you just go back with your cursor using the arrows to find where it is that you want to insert that. So I would want the 1 to come in before this 3. So I'd go and highlight that 3, and I would press second, and then this DEL, because the second button, what that will do is it will activate the blue letters right above the button. So pressing second will activate the blue letters right above the DEL, which is this INS. INS stands for insert. So I'm trying to insert a 1. So if I go and press the 1 now, since I pressed second DEL, I can put in the 1, and now I'll have 13 plus 3. But let's say I didn't actually mean to do 13 plus 3. I want to do 13 times 3. Well, I can bring back that same equation and go back, and instead of a plus, I wanted a times. Well, now instead of inserting it, I'm just going to write right on top of it. And instead of a plus, I'm going to have a times. And as long as I didn't do anything else, it will just replace whatever is under the blinking cursor with whatever it is that you type. Now, if I actually want to do this as 3 times 3 instead of 13 times 3, that would mean I need to go and get rid of this 1. If I hit clear, it will delete this entire line, so that wouldn't be helpful. But if I just hit DEL, which stands for delete, it will delete that 1, bringing it back to just 3 times 3, which would give us an answer of 9. So that's just a quick rundown on a lot of things from your calculator. But the real reason that I actually wanted to bring this up is to redo some of those problems that we had previously done. So some of those problems included 13 times n when n equaled 3. Well, something you could actually do with this calculator is you could say 3 and then press this stow button right here on the left side. And what that will do is that will store whatever you're putting in 3 as a variable. So if we were doing 3 times n, or 3 store as n, we now need to hit alpha, so it will activate all of those little green letters that you see above the numbers. And n is actually right here above the word log. So 3 stow n, and now whenever we type in an n, it will always be a 3 until we tell our calculator to do something else. So if I just go and bring up an n and say, what does n equal? N equals 3. Or 2 times n would be 6. Or 9 times n minus 2 would be 9 times 3, which is 27, minus 2 should be 25, which is what we got. So it's a little overkill for what we're doing right now, but it will actually be really helpful as we go further into our math experience together. So let's go back to our lesson for a little bit. So if we're looking at the cost of a movie, if you just think about it logically, if you go to a movie, the cost that you're going to spend is the price for the tickets and the price for the food and drinks that you need. We'll just call that refreshments. Well, we'll call the price for the ticket your price for admission. We'll just use the variable A. And the price for refreshments, we'll use the variable R. That means your total cost is going to come out to just A plus R. Now, if we have maybe, let's say admission was $7.50 a ticket, and you go and spend $7.25 to get your pop and popcorn, that now means that your cost is going to equal that $7.50 plus the $7.25 for refreshments, bring you a total cost of $14.75. One last vocab thing that we're going to talk about is powers. Now, power is an expression that represents repeated multiplication of the same factor. So for example, over here we have 3 multiplied by itself 4 times. So we can rewrite this as a power with a base of 3 and an exponent of 4. Another thing that this means is we can represent powers in multiple different forms. So for example, 7 to the first power, you could write out as 7 to the first power. Or as a product, that would just be 7. You could also have a product that's 5 times 5, which would be the same as 5 squared. And you could write that out as 5 to the second power. Or you could write it out as 5 squared. That would also work. The third one down, we have 1/2 to the third power. You could write it out as 1/2 to the third power. Or as a product, that would be the same as 1/2 times 1/2 times 1/2. Finally, we have z to the 5th power. And just as a heads up, sometimes when I do z's, I will put this little cross across it just to help show that it's a z and not a 2. So z to the 5th would be the same as z to the 5th. And as a product, that would be z times z times z times z times z. And that would be z to the 5th. So finally, for when we come down to these last 2 expressions, I'm going to actually pull those up on our graphing calculator again. So we want to do x to the 4th when x equals 2, and n to the 3rd when n equals 1.5. So first thing I'm going to do, I'm just going to clear this out so that it's easier to see what's going on. Now what we need to know is that x is equal to 2. So I'm going to do 2, and I'm going to store that as x. So we can do it as 2 stow, and then the x is actually right above the stow. So we can go alpha stow to get 2 store as x. And then we can do x to the 4th. So that would be x to the 4th. And 2 to the 4th comes out to be 16. Now another way you can do this is actually this button right here next to alpha. You don't have to press second, you don't have to press alpha, but if you just press that, it will spit out an x for you. And that's because that's your variable button. And so since x is the most commonly used variable, it's going to be using x for us. So if we want to do x to the 4th, you could go and get your x right here, to the 4th, and it will still come out as 16. Now the next question wanted n to the 3rd when n equals 1.5. Well, your calculator doesn't actually care about what variable you're using, you just need to make sure you name it correctly. So instead of using n this time, I'm going to use x again. So I'm going to say 1.5, I'm going to store that as x. So if I want to do x to the third power, that will then come out to 3.375. So that's it. That is all the more you have to do for this today. Thank you for stopping in, and good luck with this lesson. As always, let me know if you have any questions.